Assalamu alaikum everyone. Today we'll be looking at vectors. This is for Edexcel IAL P4 and Cambridge A-Levels P3 candidates. So without further ado, let's jump right in. Let's say you have a triangle and let's say I know these two vectors, which is OA vector is A and AB vector is B. Now, if I want to find out the OB vector, which means that I am at this point and I want to get to this point. But the problem is that I don't know the value of this path. But I do know the value of these two paths. So what I can say is that OB vector is equals to the OA vector plus AB vector. So it goes the same for every single vectors in this triangle. So OA vector can be written as OB plus BA vector, and BA vector, this can be written as minus AB vector since the direction is opposite. So it's up to you however you want to write it. And OB vector can be written as OA plus AB, and AB vector can be written as AO plus OB. Now there's a simple trick with finding the AB vector. It's that the position vector, which is relative, the point which is relative to all of these other points is the origin, which is O. So I can say that, let's say I want to find out the AB vector. So the second part, the second digit, second alphabet is B. So first of all, you need to write OB vector and minus the first alphabet, which is the OA vector. Now if they tell you to find out the CF vector, let's say we have CF vector and all the given vectors are relative to the origin. So you can write this as OF vector minus OC vector. Now moving on to the second part. If we have two vectors, let's say we have vector OA and vector AB, and if these two vectors are parallel to each other, parallel means that at every single point the distance is same. So this distance is equal to this distance, also the same. Let's say this distance is D, this will be D, and this will be D also. Now if these two vectors are parallel, I can say that the OA vector is equals to lambda AB vector. Lambda is a constant. The value of lambda can be 0.5 or 2 or 3, anything. But the value of lambda cannot be less than 0. This cannot be less than, this cannot be negative. This has to be a positive value. Or you can also write it like this, that AB vector equals lambda of OA vector. It doesn't matter. Now I hope you're all familiar with the ij component. Sometimes the vectors are given as 2i plus 3j. So basically the I component represents the horizontal direction and the j component represents the vertical direction. So let's say we have a vector which looks like this, which is 2i plus 3j. Now if I want to sketch this vector, first of all we need to draw the axis. In the horizontal axis, this will be the I-axis and the vertical axis will be the j-axis. So since this is 2i plus 3j, so in the I-axis it will move 2 units to the right, and in the j-axis it will move 3 units upwards. So they're basically talking about this point. So the vector will look something like this. So this is the vector. Alright. And since this I and j represents the horizontal and vertical direction, the vector 2i plus 3j can also be written in this format. This format is known as column vector. column vector. Now let's say that I want to find out the length of this vector. Let's say that the length is d. Now if I want to find out the length of this vector, let's say that the vector is 2i plus 3j. Let's call this vector a. So in order to find out the length of this vector, you need to perform the modulus function in this part. So the modulus can be written as root over 2 squared plus 3 squared. So this is root over 13 units. So this is the length of this vector. Now sometimes most of the times in A levels, especially for A levels, all the vectors and all the coordinates are given in 3D format. So the vectors won't look simple like this. It will look something like this: 2i plus 3j plus 4k. So this is the third axis. So as we all know, there are three axes. First of all, the y-axis, and the second of all, the x-axis. So this is the x-axis and this is the y-axis. Now the third axis, which is the z-axis, it looks something like this. So this is the z-axis. So basically the coordinates are given in this format: 2, 3 and -1, or the coordinates can also be given in column vector format, which is 2, 3 and -1, or this can also be given as 2i plus 3j minus k. So basically a 3D vector format looks something like this: ai plus bj plus ck. If you want to find out the length of this vector, it will be root over a square plus b square plus c square. So this is how you find out the magnitude of a vector. Now if you want to find out the unit vector is basically the vector represented by 1 unit of length. So let me give you an example. Let's say we have the vector 2i plus 3j plus 2k. So the line should look something like this. Now if I want to find out the length of this line, let's call this the OA vector. So the modulus of OA vector is root over 2 squared plus 3 squared plus 2 squared. So this is equals to root over 17 units. Now if I want to find, let's say that this is root over 17 units. If I want to find out that how much, what vector is represented by 1 unit only, let's say that the 1 unit is up to here. This is the 1 unit or 1 centimeters, however you want to say it. So I can say that root over 17 units represent the OA vector. So 1 unit can be represented by the OA vector divided by root over 17, and we know that the root over 17 is basically the modulus of OA vector. So this is actually the formula to find out the unit vector of a single vector. So the unit vector can be written as the vector divided by the modulus of the vector, and the notation for a unit vector is this symbol. Now moving on to the next part, there's a concept called the scalar product. Let's say we have two vectors. Let's say that this is point O and this is point A, and this is point B. The vectors are given as A and B. Now the angle between these two vectors is theta. So I can say that the vectors, the product of the vectors is equals to the modulus of the vectors multiplied by cos theta. So let's say that this vector is represented by 2i plus 3j, and this vector is I plus, or let's say that this is 6i. Now if I want to find out the angle of this vector between these two vectors, I would simply use this formula. That is to multiply the vectors, which is 2 and 3, multiplied by 6 and 0. Now why is it 0? It's because there's a 0j in this part. This will be equal to the modulus of the vectors, which is root over 2 squared plus 3 squared multiplied by 6 squared, root over 6 squared, which is equals to 6 times cos theta. So if we multiply these two vectors, it will be 2 times 6 plus 3 times 0. We will learn how to multiply vectors in the next part, but for now just think of it like this. This is 6 root over 4 plus 9, which is 13 cos theta, and from this equation you can easily find out the value of theta. So this is actually known as the scalar product theorem. Now if we have two perpendicular vectors, the product of the vectors will be always equals to 0, because if you apply the scalar product, which is a times b equals modulus of a times modulus of b cos 90. Why is it 90 degree? Because these two vectors are perpendicular. So we know that the value of cos 90 is 0. So the product of the vectors will be always equals to 0. Now let's look at how to multiply 3D vectors. Let's say we have two vectors, which is a, b, c and d, e, f. Now, in order to multiply these two vectors, you'd simply multiply the corresponding values and add them up all together. So it will be AD plus BE plus CF. So this will be your result. Now moving on to the next part, if you want to find the distance between 2 points in a 3D plane, let's say we have the OA vector and OB vector. Their coordinates are given as x1, y1 and z1, and x2, y2 and z2. So the distance between these 2 points will be root over x2 minus x1 whole squared plus y2 minus y1 whole squared plus z2 minus z1 whole squared. This is the formula for length. Now if we want to find out the equation of a line in a 3D plane, it's not that easy. It's not easy like finding the equation of a line in a 2D plane. To find out the equation of a line in a 2D plane, you just simply follow this rule, which is y equal mx plus c. But for an equation in a 3D plane, it's very complex. So let's look at two scenarios. The first scenario is that, let's say that a line L passes through a point with position vector A. So let's assume that this is the line L and this passes through a point, let's call this point A, and the OA vector is given as A. And this line is parallel to the OB vector. Let's assume that the OB vector looks something like this. This is point O and this is point B. So the OB vector, let's assume that the OB vector is B. Now if we want to find out this equation, the equation of this line, so the first thing is that it passes through only one point, and the second thing is that this line is parallel to the vector OB. So the equation of this line will be L equals A plus lambda B, and this lambda is a scalar parameter. Now you can ask that what is a scalar parameter? So if I look at the equation of a line in a 2D plane, it looks something like this, which is this: y equal mx plus c. This variable x is known as a scalar parameter. Scalar parameter. So this is basically the same as x. I mean, this lambda is basically the same as x. This is a scalar parameter. Now, if you look at this equation, you can see that this is in the form y equal mx plus c. So this is x and this is m. Now, as you can see that the vector b can also be known as the gradient of the line. You can just think of it like this, that the vector b is known as the gradient of the line. In further maths, we will see the application of this concept, that why do we consider b to be the gradient of the line. But for now, just think of it as the gradient of the line. So now let's look at a second scenario, which is a much simpler scenario. It's that if line L passes through 2 points with vectors a and b. Let's say that the line L, this is the line L, and this is point A and this is point B. Now, if OA vector is given as A and OB vector is given as B, the equation of this line will be L equals A plus lambda B minus A. The equation can be written like this. Or what you can do is that the equation can also be written like this: B plus lambda A minus B. We usually follow the first one, but both of them are correct. They won't give you the same answer. The equation of the line may be different. I mean, it will be different for both of these values, but both of them are correct. But we usually use the first one. It's much easier to understand. Now there's another concept which is known as the skewness of a line. Now in a question, if they tell you that two lines are skew, which means that they are not parallel and they do not intersect. Let's say that we have two lines, L1 and L2. If I say that these two lines do not, I mean, if these two lines are skew, let's say L1 and L2 are skew, which means that these two lines will not intersect. So that is basically the meaning of skew. So now let's look at some questions regarding vectors. I hope solving this question will clear up all your confusions in the vector topic. Now let's first look at the question from a recent paper, which is May 2023, question 4. So relative to a fixed origin O, so the vector OA vector is given and OB and OP vector is also given. Now the straight line L passes through A and B. Now we need to find a vector equation for line L. So for line L, we can write this as L equals A plus lambda B minus A. The vector equation can be written like this, as the line passes through both of these points. So we know that for vector A, I mean the OA vector can be written as 4, 8, 1. 4, 8 and 1. plus lambda, the OB vector minus the OA vector. So it will be 5 minus 4, and 6 minus 8, and 3 minus 1. So this can be written as 481 plus lambda 1 minus 2 and 2. So this is the answer to the first question. Now let's move on to the second question. Is that the point C lies on the line L, so that PC is perpendicular to L. Now we just need to find the coordinates of C. Now in order to do these kinds of sums, you would need to consider the line L. Let's assume that the line L looks like this, and this is, so the point C lies on line L. Let's say that this is the point C, and this is the vector, this is the point P. Now the PC vector is perpendicular to L. So first of all, we need to find out the OC vector. Since the point C lies on the line L, we can say that the OC vector is equals to 4 plus lambda and 8 minus 2 lambda and 1 plus 2 lambda. We do not know the value of lambda yet. This is basically the equation of line L. Now since these two vectors are perpendicular, the line L and the PC vector is perpendicular, let's first find out the PC vector. So the PC vector can be written as OC vector minus the OP vector. We know that the OC vector is 4 plus lambda and 8 minus 2 lambda and 1 plus 2 lambda minus the OP vector. The OP vector is 2 minus 2 and 1. So that's 2 minus 2 and 1. So this can be written as 2 plus lambda times 10 minus 2 lambda and 2 lambda. You just need to subtract the corresponding values. So this is the PC vector. Now since this is the line L, this is where the concept comes in, that this can be written as the gradient of the line. So I can say that PC vector multiplied by the gradient of the line. For this, the gradient of the line is 1 minus 2 and 2. So PC vector times 1 minus 2 and 2 will be equal to 0 since they are perpendicular. Now we just need to solve this equation. So PC vector is lambda plus 2 and 10 minus 2 lambda and 2 lambda multiplied by 1 minus 2 and 2. This is equals to 0. Now if I multiply the corresponding values, I should get the answer. So 1 multiplied by lambda plus 2 and minus 2 multiplied by 10 minus 2 lambda and plus 2 multiplied by 2 lambda will be equal to 0. So from this we can find out the value of lambda at point C. So the value of lambda is 2. Now we just need to find out the coordinates of C. We know that the OC vector is 4 plus lambda, 8 minus 2 lambda and 1 plus 2 lambda. If we substitute the value of lambda into this equation, we should get the coordinates of C. So the value of lambda is 2. So 4 plus 2 will be 6 and 8 minus 4 will be 4, and 1 plus 4 will be 5. So the coordinates of C can be written as 6, 4 and 5. So this is the answer to part B. Now the point P prime is the reflection of P in the line L. Now we just need to find the coordinates of P prime. So if I reflect point P in the line L, so it should give us this new coordinate, which is P prime. Now if this has a distance of D, this distance will also be the same, D. So I can say, since this is the point C, I can say that P prime vector is equals to twice of PC vector. Now we just need to find out the value of PC vector. We know that at point C the value of lambda is 2. So if we substitute the value of 2 into the PC vector's equation, this will be 4 and 6 and 4. So this is the PC vector. We just need to multiply it by 2. So this should give us a value of 8, 12 and 8. So this is the P prime vector. Now we just need to find out the value of OP prime vector. So let's assume that point O is somewhere around this part. We can say that the OP prime vector can be written as the OP vector plus P prime vector. So the OP prime vector can be written as OP vector plus P prime vector. So the OP vector is 2, minus 2 and 1, and the P prime vector is 8, 12 and 8. So this will be equal to 10, 10 and 9. So the coordinates of P prime will be 10, 10 and 9. So this is the answer to the third part. Now we just need to find out the P prime vector, the modulus of P prime vector. So in order to find out the modulus, we can say that the modulus of P prime vector is root over 8 squared plus 12 squared plus 8 squared. It's basically this vector. So this will be equal to around 4 root over 17. So that is it for the first question. So let's move on to the second question. This is also a question from a recent paper, which is the January 2023 question 6. So let's get on with it. So first of all, they have given us the OA vector and the OB vector. The OA vector and the OB vector, and we know that the line L passes through A and B. So first of all, we need to find out the AB vector. So the first question is to find out the AB vector. So we know that the AB vector can be written as OB vector minus the OA vector. So OB vector minus OA vector, so 8 minus 2, which is 6i, and 3 plus 3, which is 6j, and minus 7 minus 5, which is minus 12j, minus 12k. So this is the AB vector. Moving on to the second part, we need to find the vector equation for the line L. So we know that the line L passes through A and B. So L will be equal to A plus lambda B minus A. Now there's another small part which I did not tell you before. I mean, when explaining to find the equation of a line in a 3D plane. Now let me just tell you this now, that this must be in the simplest form. This must be in the simplest form. Simplest form. So let me just demonstrate how to write this. So first of all, the OA vector, which is 2 minus 3 and 5, 2 minus 3 and 5 plus lambda b minus a, and b minus a, we know that this is the AB vector, because AB vector can be written as OB, which is the vector B, minus OA, which is the vector A. So B minus A vector is 6, 6 and minus 12. Now this must be in the simplest form possible. So the simplest form of this is, if you take 6 common, this can be written as 1, 1 and minus 2. So you actually need this value. You can exclude this value. You can exclude this constant value, which is 6. So you have to write this in 1, 1 and minus 2 format. So this is the equation of your line. Now moving on to the second part, we know that the OC vector is given and point P lies on L and CP is perpendicular to L. So let's say that this is the line L. Now point P lies on L. Let's assume that this is the point P and this is the point C. Now CP is perpendicular to the line L, which means that if I multiply CP by the gradient of line L, it should give us a value of 0. So let's first find out the OP vector. So we know that since P lies on the line L, the OP vector, the coordinates of P, can be found using this equation. We just don't know the value of lambda, so this can be written as lambda plus 2 and lambda minus 3 and 5 minus 2 lambda. So this is the OP vector. Now in order to find out the CP vector, which we need, this can be written as OP vector minus the OC vector. So the OP vector is lambda plus 2 and lambda minus 3, 5 minus 2 lambda, minus the OC vector, which is 3, 5 and 2. It is 3, 5 and 2. So this is equals to lambda minus 1 and lambda minus 8 and minus 2 lambda plus 3. So that is the CP vector. Now if I multiply the CP vector by the gradient of line L, so the gradient of line L is 1, 1 and minus 2. So that's 1, 1 and minus 2. This should give us a value of 0 because they are two perpendicular vectors. So we know that the CP vector is equals to lambda minus 1 and lambda minus 8 and minus 2 lambda plus 3 multiplied by the gradient of line, which is 1, 1 and minus 2. This should give us a value of 0. Now we just need to multiply the corresponding values. So it's lambda minus 1 and lambda minus 8 and minus 2 lambda plus 3. This is equals to 0. So from this equation we can find out the value of lambda. So the value of lambda is 5 over 2. Now we need, in the question they have asked us to find out the position vector of P, so we need the OP vector. So if I substitute the value of lambda into this equation, I should get the OP vector. So if I substitute the value of lambda into this equation, this should give us a value of 2. So it's 9 over 2 and minus 1 over 2 and 0. So since they're talking about the position vector, we need to write this in I and j format. So it's 9 over 2i minus 1 over 2j. So this is the answer. Now moving on to the next question. This is a question from October 2022, question 9. They have given us two lines, which is the line L1 and L2. The equations are given. Now we need to prove that these two lines are skew. Skew means that they do not intersect. In order to prove that they are skew, which means they do not intersect, let's assume that these two lines do intersect. If they do intersect, we can equate the equations of these two lines. So it's 2, 8, 10 plus lambda, or you can just write it like this, which is 2 minus lambda and 8 plus 2 lambda and 10 plus 3 lambda. This is equal to the equation of L2, because we're just assuming that these two lines do intersect. So it's minus 4 plus 5 mu and minus 1 plus 4 mu and 2 plus 8 mu. So since these two values are equal, we can equate the corresponding values. So we can say that 2 minus lambda is equals to minus 4 plus 5 mu. So if we rearrange this equation, this should give us a value of lambda plus 5 mu equals 6. So this is our first equation. Now in order to find out the second equation, we can equate the second pair of values, which is 8 plus 2 lambda and minus 1 plus 4 mu. Minus 1 plus 4 mu. Now if I rearrange this equation, this will be 2 lambda minus 4 mu equals minus 9. So this is our second equation. Now if we solve these two equations, we should get our values of lambda and mu. So the value of lambda is minus 1.5 and the value of mu is 1.5. Now moving on to the third pair of value, which is the last one. Let's say that I want to substitute the value of lambda into this equation. I should get the same value of mu if these two lines do intersect each other. So if I substitute the value of lambda into this equation, which is minus 1.5 equals 2 plus 8 mu, I should get the value of mu to be 1.5. If the value of mu is not 1.5, it means that these two lines are skew. Now as you can see that the value of mu is actually 7 over 16, which is not equal to 1.5. Now you can end with a conclusion is that the lines are skew. So that is it for this question. Now moving on to the next question. This is a question from May 2022 and this is question 6. So in this question they have given us the OA vector, OB and OC vector. We just need to find out the equation for line L, and we know that the line L passes through A and B. So we can write down the equation for line L as L equals the vector A, the OA vector plus lambda OB vector minus the OA vector. So the OA vector is actually 1, minus 4 and 3. So that's 1, minus 4 and 3 plus lambda B minus A. So it's 5 minus 1, which is 4, and 3 plus 4, which is 7, and minus 2 and minus 3, which is minus 5. So this part is at its simplest form, so we don't need to simplify this further. So this is the equation for line L. Now given that AC vector is perpendicular to line L, so let's first find out the AC vector. So the AC vector is equals to OC vector minus the OA vector. So the OC vector minus the OA vector, which is 3 minus 1, which is 2, and P plus 4. P plus 4. And the other one is minus 1 and minus 3, which is minus 4. So this is the AC vector. Now we know that the AC vector is perpendicular to line L. So if I multiply the AC vector, which is 2 and P plus 4 and minus 4, multiply this AC vector with the gradient of line L. The gradient of line L is 4, 7 and minus 5. So that's 4, 7 and minus 5. This should give us a value of 0 since these two are perpendicular vectors. So now let's multiply the corresponding values and add them up all together. So it's 8 plus 7 times P plus 4 plus 20 equals 0. So from this equation we should get our value of P. So the value of P is minus 8. So that is it for this part. Now moving on to this next part, we need to find the area of triangle A, B and C. So we know that, let's assume that this is the line L, and line L passes through A and B. So this is the point A and this is the point B, and we know that the AC vector is perpendicular to line L. So the point C will lie somewhere around this part. So this forms a triangle like this, and this triangle is a a right angle triangle. So now we just need to find out the length of AB and AC and use the formula half base height to calculate the area. So in order to find out the length of AB, we need to find the modulus of AB. So the modulus of AB will be, so AB vector is 4, 7 and minus 5. So it's 4, 7 and minus 5. So this will be 4 squared, 7 squared and minus 5 squared, which gives us 25. So this is equals to root over 90. So that is the AB vector. Now we need to find out the AC vector. And we know that the AC vector is 2P plus 4 and minus 4. So let's just substitute the value of P into this equation. So it's minus 4 and minus 4. So this is the AC vector. Now let's calculate the modulus of AC vector. So the modulus of AC vector is, AC vector is 2 squared plus 4 squared plus 4 squared. So that's 4 plus 16 plus 16. So this is equals to around 6. So the area of triangle ABC, area of ABC is equals to half times base times height, which is root over 90. So this will be equal to around 9 root over 10 units squared. So that is it for this question. Now moving on to the next question. This is our last question. This is a question from January 2022, question 8. We have two position vectors, which is the OA vector and OB vector, and the line L1 passes through the points A and B. Now, first of all, we need to write down an equation for line L in the form R equals P plus lambda Q. So for line L1, let's say that the equation is R equals, since this passes through both of these points, so it will be A plus lambda B minus A. So the column vector for A is 6, 6 and 2, and B minus A will be 0 and minus 6 and 5, and this is already in its simplest form, so we do not need to simplify this further. So now this is the equation of line L1. Now for the second part, the line L2 has equation this. Show that line L1 and L2 do not meet. Now let's just assume that these two lines do meet. So if these two lines meet, we can just equate the equations of the line. So we can say that if we take this equation, this will be 6 and 6 minus 6 lambda and 5 lambda plus 2. The L1's equation will be equal to the L2's equation. The L2's equation can be written as mu plus 3 and 5 mu plus 1 and 9 mu plus 4. Now let's equate the corresponding values, which is 6 equals mu plus 3. So the value of mu is 3. Now let's equate the second pair of values, which is 6 minus 6 lambda is equals to 5 mu. The value of mu is 3 plus 1. So the value of lambda is around minus 5 over 3. Now if we equate the third pair of values, which is the last values, let's say that I want to substitute the value of, you can substitute any one of the values of lambda or mu. Let's say that I want to substitute the value of mu, so I should get the value of lambda as minus 5 over 3 if these two lines do meet. So this will be 5 lambda plus 2 equals 9 mu plus 4. So if lambda is not equal to minus 5 over 3, we can end with a conclusion saying that these two lines do not meet. So let's calculate this. So as you can see that the value of lambda does not match. So it's 29 over 5, which is not equal to minus 5 over 3. So we can say that L1 and L2 do not meet. So that is it for this question. Now let's move on to the next part. Now for the next part, the point C lies on L2 where mu equals 1. So when the value of mu is 1, that is where the position vector of C lies. So we can say that when mu equals 1, the value of R is, oh wait, let me just calculate this. So that's, oh, it's not 1, it's negative 1. So it's minus 1 plus 3, which is 2, and minus 5 plus 1, which is minus 4, and minus 9 plus 4, which is minus 5. So this is the position vector of C. So this is the OC vector. Now let's calculate the AC vector. We can say that the AC vector is equals to the OC vector minus the OA vector. So the OC vector is 2, minus 4 and minus 5, minus the OA vector. The OA vector is 6, 6 and 2. 6, 6 and 2. So the value of AC vector is minus 4 and 2 and minus 7. So we know that we don't know anything, we just need to find the acute angle between AC and L2. Now let's say that the AC vector looks like this. This is the point A and this is the point C, and line L2 looks like this. This is basically the slopeness of line L2, which is basically the gradient of line L2. We just need to find out this angle theta. So we know that the AC vector, we're using the scalar product. Using the scalar product, we can say that the AC vector multiplied by the gradient of line L2. So the gradient of line L2 will be 159. So that's 159. This will be equal to the modulus of both of these vectors. So let me just write down the value of AC vector first. So that's minus 4 and 2 and minus 7 equals to the product of the modulus of both of these vectors. So it's 16 plus 4 plus 49 multiplied by root over 1 plus 25 plus 81 multiplied by cos theta. So from this equation we can find out the value of theta. Let's multiply these two vectors first. So the value of these two vectors will be minus 4 plus 10 minus 63. I just multiplied the corresponding values and added them all together, and this will be root over 69 times root over 26 plus 81, which is equals to root over 107 times cos theta. So from this equation we can easily find out the value of theta. Oh, okay, so there was a slight mistake in the sum, that minus 4 and minus 6 will be equal to minus 10. It's not 2, it's minus 10. So that's minus 50. And this will be 16 plus 100. Oh shit. Plus 100 plus 49. And this will be 165. So if you apply the cos inverse negative 117 over root over 165 times 107, this will give you an angle which is not acute angle. It's basically an obtuse angle which is greater than 120. This should give you an answer of 151 degrees. Now you need the acute angle, because they have said that you need to find out the acute angle. So if you subtract the 151 degrees from 180 degrees, you should get a value of 28.3 degrees. So this will be your answer. So that is it for this question. And this is the end of the P4 and P3 vectors. And I'll see you guys in the next video.